Assalamualaikum. My name is Nordini Hafina binti Shamsuddin. I am from Group 4, which consists of 6 group members. Will present about application of multiple integrals. Application of multiple integrals consists of two types, which is for lamina and for solid. Now, I will do an introduction about lamina. A planar lamina or plane lamina is a figure representing a thin, usually uniform or flat layer of the solid. It also serves as an idealized model of a planar cross-section of a solid body in integration. It can be used to determine moments of inertia, center of mass of flat figures, as well as aid corresponding calculation for 3D bodies. For lamina, there are non-homogeneous and homogeneous lamina. The difference between homogeneous and non-homogeneous lamina is homogeneous lamina is defined when the lamina has regularly shape or symmetry and by the same material. For determine a lamina is a homogeneous, we must check the lamina is symmetrical or not. Meanwhile, for non-homogeneous is defined when the lamina has non-regularly shape. We have to employ the double integrals to find its centroid. These are an example of homogeneous lamina and non-homogeneous lamina, where A and B is homogeneous lamina, meanwhile for C is a non-homogeneous lamina. To calculate mass for lamina, M equals to mass of R equals to density, which is rho xy times area, which is double integral dA, which will we get double integral R rho xy dA. For the density function, rho xy can be a constant or an expression in terms of x and y.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mimi Zaratuhanim. I will continue to explain about the moment of mass. Okay, moment of mass is the measure of the tendencies of a lamina to rotate about the x-axis and y-axis with respect to the x-axis and y-axis. Okay, this is a formula for the moment to respect x-axis, and this is a formula for the moment to respect y-axis. After calculate at the moment x-axis and y-axis, it can obtain the center mass for lamina. This is a formula for center of mass of R. After that is about center of mass and centroid. Okay, center of mass of planar lamina xy is the balance point of the lamina. Okay, this is a formula for center of mass. Okay, due to particular case, we use the term centroid instead of center of mass. Okay, this is a formula for centroid. Next, moment inertia. Okay, moment inertia is defined as a measure of tendency of matter to resist a change in rotational motion. Okay, this is an example of the formula for moment inertia.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Najah binti Arifin and the metric number is F2Z0147. So next I'm gonna continue question number 2. First is introduction of solid. In our reality life, all types of objects exist. For instance, cups, telephones, flowers, shoes, even a piece of paper are in 3 dimensions and not the 2 dimensions as shown as in the cartoon programs. This 3 dimension is called a solid object. Solid can be defined as an object who has length, width, and height. The most common solid shapes in mathematics are sphere, parabolic, cone, hemisphere, rectangular, cube, cylinder, and also plane shape. Next is about the differences between homogeneous and non-homogeneous solid. For homogeneous, all of the constant terms in a homogeneous system of linear equations are zero. There is always at least one solution in a homogeneous system, which is the zero vector, while non-homogeneous system has a homogeneous counterpart, which you can obtain by adding the constant term in each equation. So these two is the differences equation about between homogeneous and non-homogeneous. And next is mass. Mass is defined as how much comprise an object. Mass despite in its international system of unit measure of kilograms is often confused with weight, which is the gravitational attraction between an object and the Earth. Mass is calculated as the product of an object volume and density. A measure of how much matter is in an object. The gold bar is quite small but has a mass of 1 kilogram, about 2.2 pounds, so it contains a lot of matter. Mass is commonly measured by how much something weighs, but weight is caused by gravity, so your weight on the moon is less than here on Earth. While the mass stays the same, mass is measured in grams, kilograms, and tons, metric or ounce, and pounds in US unit. So that's all from me. Thank you.
Hi, my name is Amira Afika binti Abdul Manap, CF200157. Moment of mass. Moment of mass is to measure the ability of a solid to resist changes in rotational speed around a specific axis. Top, the larger the mass moment of inertia, the smaller the angular acceleration about the axis. Moment of mass also specified with two subscripts and is dependent on a reference axis. The clarity of 3D motion involving rotation around multiple axes. Next is about the center of mass and centroid. Center of mass and centroid is similar, which is the notion of a balancing point of a plane figure, the center point in the body or particle system where the mass appears to be concentrated, and it comes out from the average or center point of the shape or solid object. For example, like in the figure, there is a red dot in the middle of the shapes. It is the centroid of shapes. This is the triple integrals of centroid or center of mass. Next is moment inertia. Moment inertia is also known as rotational inertia. It is to measure a rotation direction change of an object's resistance. And the unit for moment inertia is I. This is the formula of finding the moment inertia using triple integrals. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fikri bin Muhammad Noor, CF200222. We present question 3 in our project. Okay, given that a triangular lamina with version in bracket 0, 0, in bracket 0, 1, in bracket 1, 0, and the theta function delta in bracket xy equal x. find mass, moment of mass, center of mass, and moment of inertia lamina. Okay, this is the diagram. Okay. First step, we need to find mass and moment mass. Okay. To find mass, m equal delta radius in bracket x, y, and a area equal integrate x equal 0, x equal 1, integrate y equal 0, y equal 1, x dy dx. Okay. Next, equal that integrate 0, 1, x in bracket xy. So we need to integrate dy. So dy 0, 1 minus x dx. Okay. We got integrate 0, 1 x in bracket 1 minus x dx. And we got answer 1 over c. Okay. Next, we need find moment of mass about y-axis. First step, we need to get a formula. Integrate r, double integrate r x delta bracket x comma y dA equal delta integrate x equal 0, x equal 1, integrate y equal 0, y equal 1 minus x square dy dx equal integrate 0, 1 in bracket x square y 0, 1 minus x dx. Integrate 0, 1 x square in bracket 1 minus x dx. And we got answer 1 over 12. Okay. Next, we find for x-axis. So we use same formula and equal integrate x equal 0, x equal 1, integrate y equal 0, y equal 1, minus x, sy dy dx. So we need to integrate dy. So we got 1 over 2 integrate 1, 0, 1 x in bracket 1 minus x square dx. So we got answer and we integrate dx and we got answer 1 over 4. Okay. For next, we find for center of mass. So before this, we got answer for axis for moment of mass axis x and y. So we put in this bracket and we got 1 over 12 divide 1 over 6 comma 1 over 4 divide 1 over 6, and we got center of mass for x 1 over 2, for y 3 over 2. Okay. And the last step, we need to find moment of inertia. Moment of inertia about y-axis. So we use this formula, double integrate r x square delta in bracket x comma y dA. Okay. Integrate x equal 0, x equal 1, integrate 0, y equal 1 minus x, xy, x power of 3 dy dx. Next, integrate 0, 1 in bracket x power of 3 y 0, 1 minus x dx. So this we integrate dy and we got integrate 0, 1 x power of 3 in bracket 1 minus x dx, and we got answer 1 over 20. Okay, for next we find for x-axis and we use this formula. Double integrate r radius y square delta in bracket x comma y in bracket dA. Integrate x equal 0, x equal 1, integrate 0, y equal 1 minus x y square dy dx. Okay, we integrate dy, and we got integrate 0 1 in bracket x y3 y power of 3 over 3 0 1 minus x dx, and we got after integrate dy, and we got 1 over 3 integrate 0 1 x in bracket 1 minus x power of 3 dx, and we got answer 1 over 12. Okay, and last step, we find for moment of inertia about the origin. Okay, formula is moment of inertia exists x plus exists y. So we got 1 over 12 plus 1 over 20, and we got answer 2 over 15. I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Rabiatu Adawiyah binti Nasri. My metric number CF200070, and I would like to continue the presentation. This presentation of question 3B. Okay, let's start. The 3B requires a question of give one real problem example in your field for finding mass, moment of mass, center of mass, or centroid, and moment inertia of solid at set box. So, for the question, I choose the three-dimensional solid shape, which we can look like a triangular shape at the x, y, z axis. Suppose that Q is a solid region bounded by x plus 2y plus 3z equal to 6, and the coordinate of the x axis and at y axis 0, 3, 0, and the z axis 0, 0, 2, and the xyz has a density role. xyz equal to x square times yz. Okay, for finding the total mass, we know that the region Q is a tetrahedron shape, which the axis at point x, and y and z. Okay, to find the limit of integration, we let the z equal to 0. This is supposed as z1 in the slanted plane, and z2 is 1 over 3 times 6 minus x minus 2y. Then for x and y, we find the projection of Q onto bounded by the axis and the lines x plus 2y equal to 6. Hence, the mass of a three-dimensional solid Q we calculate by triple integral rule multiplied by x, y, z multiplied by dv. Where the first integral x1 equal to 0, x2 equal to 6, y1 equal to 0, y2 equal 1 over 2 times 6 minus x, and z1 equal to 0, z2 equal to 1 over 3 times 6 minus x minus 2y, and integrate by x square root yz dz dy dx, and the total we get is 100x over 35, which is in the Demican number is 3.0086. Okay, for finding the moment of mass, we should finding the yz plane, which is the moment of mass at fxy. We do a triple integral of z rule multiply xyz multiply dv. So we got which is the moment of xy axis is x square root yz square root dz divided x, and the total we got is 54/35, which is the meter value is 1.543. Next, moment of mass at z plane. We do a triple integral at the value of xt1/35, and or it can read as 2.314, and at the yz plane we got the value x square yz dz divided x using the same value of x1 x2 y1 y2 z1 z2. We got the value of 235, which is we can read as 6.943. Next, for finding the center of mass or centroid, we use the formula the moment of mass equal to total center of x-axis 2.250, and at y-axis we got 0.750, and at the z-axis we got the value 0.5. Then the center of mass for the tetrahedron cube is the point of x, y, z, 2.2t, 0.750, and 0.5 respectively. Okay, last but not least, we find the value of moments of inertia of a solid, where is moment of inertia of the tetrahedron cube about the yz plane, the xz plane, and the xy plane. The total moment of inertia at x plane, we got the value. We do a triple integral of y square plus z square times rho xyz times dv, and using the same value of x1, x2, 1, z2, we got the value of 117/35, which is 3.343. And then for the inertia of at y axis, we done the same steps, and we got 600. And to calculate moment inertia of a solid IY, we do a triple integral with x square minus z square times rho times xyz times dv, and using the same value of x1, x2 until z, we got the value 664/35, which is 19.543. The last one, moment inertia of Iz, we do triple integral by x square minus y square times rho times xyz times dv, and we got the value of 729/35, which value is 20.829. Thus, the moment inertia of the tetrahedron Q about the yz plane and the xz plane and xy plane are 3.343, 19.543, and 20 points respectively. Okay, that's all from me. Thank you.
Okay, finally, for conclusion, from question 1, we analyze more details about planar lamina, such as explanation about mass, moment, center of mass, and so on. Okay, for question 2, we define and explain more details about the introduction for solid and about the formula which is using in this application. From this question, we know the differentiation about planar lamina and types of solid. Okay, for question 3, we can solve the question correctly. For example, to find moment of mass of solid, we can apply these applications to our real problems. Last but not least, we can say that through the multiple integrals technique can take care of effectively the issue. That's all from us. Thank you very much.